Hi, in this video we are going to see about stability analysis using root locus method. Outline. So first we are going to see about the root locus definition and how to construct the root locus and advantages and disadvantages of the root locus techniques. The definition. A root locus is a graphical representation showing how the closed poles of a system change as a parameter. Typically a gain varies. It is a tool in control theory and stability analysis, helping engineers understand how system poles move in the complex plane as the gain changes, which affects stability and performance. The root locus is a plot in the complex S-plane, where each point on the locus represents a possible location of the closed loops for a specific value. The set of rules to construct the root locus. The first rule is locate the pole locate the open loop poles and zeros in the S-plane. We know that the root locus branches start at open loop poles and end at open loop zeros. So the number of root locus branches n is equal to the number of finite open loop poles or the number of finite open loop zeros, whichever is greater. Rule number 2, find the number of roots locus branches. If the angle of the open loop transfer function at a point is an odd multiple of 180 degree, then the point is on the root locus. If odd number of the open loop poles and zeros exist to left side of a point on the real axis, then the point is on the root locus branch. Therefore, the branch of point which satisfies this condition is the real axis of the root locus. So the rule 3 is used to identify and draw the real axis root locus branches. Rule number 4, find the centroid and the angle of asymptotes. By using these formulas, we can find the centroid and asymptotes. To find the centroid, which is given as alpha, which is equal to summation of real part of finite open loop poles minus summation of real part of finite open loop zeros divided by P minus Z. The formula for the angle of asymptote is theta is equal to 2q plus 1 into 180 degree divided by P minus Z. Activity. So from these two images, find the 10 differences. So the answer for the activity is given in this slide. Next, rule number 5. Find the intersection points of root locus branches with an imaginary axis. So if all elements of any row of root array are 0, then the root locus branch intersects the imaginary axis and vice versa. Identify the row in such a way that if we make the first element as 0, then the element of the entire row are 0. Find the value of k for this combination. Substitute this k value in the auxiliary equation. You will get the intersection points of the root locus branch with an imaginary axis. So rule number 6, find breakaway and break-in points. The steps to find breakaway and break-in points are, if there exists a real axis root locus branch between two open loop poles, then there will be a breakaway point in between these two open loop poles. If there exists a real axis root locus branch between two open loop zeros, then there will be a break-in point in between these two open loop zeros. Write k in terms of s from the characteristic equation 1 plus g of s h of s, which is equal to 0. Differentiate k with respect to s and make it equal to 0. Substitute these values of s in the above equation. The values of s for which the value k is positive are the breakpoints. Rule number 7. Find the angle of departure and the angle of arrival. The formula for the angle of departure psi d is equal to 180 minus psi. The formula for the angle of arrival psi a is 180 plus theta. The angle of departure and the angle of arrival can be calculated at complex conjugate open loop poles and complex conjugate open loop zeros respectively. The root locus advantages. A major advantage is the ability to easily visualize the impact of gain adjustment on system stability, helping determine optimal gains for desired damping characteristics. We can find the stability of system from root locus. Gain margin, phase margin can be determined from root locus. Performance of the system can be predicted through root locus. We can find roots of characteristic equation using angle and magnitude condition. And it is easy to implement. Root locus disadvantages. Root locus techniques can be applied only to linear time invariant system. It is not suitable for discrete time system. Used only for the analysis of closed loop feedback system. We can find the stability of system from root locus. Gain margin, phase margin can be determined from root locus. Used only for the analysis of closed loop feedback system, it becomes more complex for multiple input-output system. Time delay system is hard to analyze through it. Summary. Through this, we get to know about the stability of system by plotting open loop zeros and poles of transfer function and by varying k parameter or gain parameter of system. It is also helpful for doing the performance analysis of the system. By plotting open loop poles and zeros, we also get to know about their contribution in stability of system. We can also modify and add open loop poles and zeros to make system stable, unstable, conditionally stable or marginally stable as per our needs. Root locus technique is very important method for the designing and analysis of control system. Thank you.